Morning students, myself Lakshmi Prasanna, working as assistant professor in School of Agriculture, Department of Soil Science and Agriculture Chemistry, SR University, Warangal, Telangana. As part of our soil science course, Management of Problem Soils and Irrigation Water, today I am going to discuss about the topic acid sulfate soils. Before going to the acid sulfate soils, I want to give a brief description about this acid sulfate soils. So acid sulfate soils are the type of the problematic soils which are commonly present in many parts of the world. So these are naturally occurring soils which contain iron sulfide mineral commonly known as the pyrites. When these soils are exposed to the air due to the drainage, excavation or due to drought conditions or by doing the tillage practices, these soils when it get exposed to the oxygen, they get oxidized and iron sulfides are converted into the sulfuric acid, which becomes more and more acidic, making the pH less than 4. This acidification releases various types of elements like hydrogen, aluminium, and other heavy metals into the environment, causing greater damage to the plant growth, economic yield, soil health, and by degrading the soil quality and also the water quality. These soils are also known as or described as the nastiest soils in the world because these soils have the negative impact on the environment. So let's see the overview of this acid sulfate soils. So this PPT includes this introduction, types of acid sulfate soils, formation, characteristics of acid sulfate soils, what are the indications for the determination of these or formation of these acid sulfate soils, problems of soil acidity, problems of acid sulfate soils, reclamation and management measures. So let's see the introduction of these acid sulfate soils. So acid sulfate soils are present in many parts of the world. So acid sulfate soils are generally saturated with water and it is oxygen free, that is the anaerobic condition, and it contains the microscopic crystal forms of iron sulfide mineral, which is commonly known as pyrites. So these acid sulfate soils are generally safe and harmless when it is not disturbed, when it is not in a disturbed condition. If acid sulfate soils are dug or when it is drained or aerated, these soils come in direct contact with the oxygen. These pyrites which are present in that particular soil, it comes in contact with the oxygen and it gets oxidized. In the oxidation phenomena, the pyrite, that is FeS2, is converted into it gets oxidized and it is converted into the sulfuric acid, which is caused into the environment. This acid also attacks the various types of soil minerals by releasing the aluminium ions, iron ions. Rainfall also, when there is heavy rainfall in that particular area, these minerals are released into the environment, causing the damage or degradation of the soil environment, also the soil degradation. So here you can see the microscopic view of pyrites mineral. Pyrites, that is the iron sulfide mineral, which is present in this, especially in this acid sulfate soils. So in the next slide, we are going to see this. What is the definition of acid sulfate soil? So acid sulfate soils is the soils which are generally present in the lowland areas or the coastal areas. So these soils are present in the coastal areas having the clay and sand which contain sulfur bearing minerals present in them. So these soils are formed by the action of the anaerobic bacteria in the presence of organic matter, in the presence of seawater, and also with the organic matter. These organic acid sulfate soils are generally stable. They are stable in an unoxidized state. I mean, these soils are stable in the anaerobic condition in unoxidized state. But if these soils are exposed to the air or environment, these soils become oxidized by the action of the oxidation phenomena and gets converted into the sulfuric acid. So acid sulfate soils are come into two categories, that is potential acid sulfate soils and also the actual acid sulfate soils. So these are the different pics which depicts the formation of these acid sulfate soils. So here you can see the pic where there is yellow color appearance in these acid sulfate soils, which is the presence of pyrites mineral present in them. And this is the soil where acid sulfate soils are the waterlogged soils or the saturated soils. So this is the saturated condition where these acid sulfate soils, and this is as the soils are saturated and waterlogged over a long period of time, these soils are soft and sticky in nature. Soft, sticky, and having the yellow appearance. It is due to the presence of the mineral pyrites and also due to the degradation of the organic matter. Formation of acid sulfate soils. So in the formation of acid sulfate soils, as we have discussed below in the previous slide, so generally these acid sulfate soils are present in the coastal areas or in the swampy areas or in the estuaries. So in the swampy areas or in the coastal areas, the land, the water which is coming from the sea waters. So in the coastal areas where there is acid sulfate soils, seawater is inundated into the particular lands. So seawater contains different types of salts present in there. So in these different types of salt, sulfate is the major salt which is present in that salt waters. When this sulfate compound, when these sulfate ions are generally poor aerated, and it is present in the, when this sulfate ion, when it enters into these particular soils, so it is in a reduced condition in the, and it is present in the anaerobic condition as the waters are low, as the water is saturated or waterlogged condition. That is why the soils are in the anaerobic condition. So in the anaerobic condition, these soils, that is the sulfate which is present in the soil, gets reduced and it is converted into the sulfides with the presence of the sulfur reducing bacteria, that is desulfovibrio. Desulfovibrio is the sulfur reducing bacteria which converts sulfate into sulfides. So when there is conversion of this sulfate into sulfides, these soils are not, these soils are very less acidic in nature when they are first drained in water. When these sulfides containing soil, when it is again drained or aerated, or it is when it undergoes the tillage operation, or when this particular soil gets exposed to the air, these sulfides which are present in that particular soil gets oxidized to sulfate by the combination of the chemical and bacterial actions, forming sulfuric acid. So here the oxidation phenomena takes place. So the main bacteria responsible is the sulfur oxidizing bacteria, that is the Theobacillus ferrooxidans. So here you can see the chemical reaction present over here, that is formation of pyrites and formation of sulfuric acid. In the first phenomena, the sulfates are the iron which is present in the sediments or in the soil, and the sulfate which is present in the sea water, and the presence of the organic matter. This sulfate which is present here, it is converted into the sulfides, that is known as the pyrites. So here the main bacteria responsible is the sulfur reducing bacteria. Here the sulfate is reduced to the sulfite. Sulfate is reduced to the sulfite. The bacteria responsible is the sulfur reducing bacteria, that is desulfovibrio. And in the second action, the sulfides which is formed here, and it gets combination with the oxygen which is present in the environment, and it is converted into the sulfuric acid. That is, sulfides is converted into the sulfuric acid. Sulfide gets oxidized and converted into the sulfuric acid. And the bacteria responsible is the sulfur oxidizing bacteria, that is the Theobacillus ferrooxidans. So in the first formation, first is a reduction takes place, that is conversion of sulfate to the conversion of sulfides, that is the bacterial reaction, that is the sulfur reduction takes place. And in the second action, that is conversion of sulfides into sulfuric acid, conversion of sulfides or elemental sulfur into the sulfuric acid by the sulfur oxidizing bacteria, that is the Theobacillus ferrooxidant. Here sulfur is the main compound as it is the acid sulfate soils. The magnitude of this acid development depends upon the amount of sulfite or sulfur compounds present in them and the conditions the time of the oxidation. So the iron pyrite which is present here, it is oxidized and it is when iron pyrite in the first phenomena the soils are not very less acidic in nature. But in the second phenomena, in the oxidation phenomena, the soils become more and more acidic, having the pH less than 4. It is due to the formation of sulfuric acid. So this is the sulfidization process. These soils are mostly common in the coastal areas, coastal lands, coastal lowland areas, estuarine areas, mangroves, estuarines, swampy areas are the deltaic regions. And in the particular countries like having the tropical and subtropical climates, including the parts of Bangladesh, India, Bangladesh, Vietnam, and Australia. So in these countries, these acid sulfate soils are the most dominantly present. So this diagram depicts the formation of these acid reduction phenomena. So here the sulfate which is present in the brackish water, sorry, the sulfate which is present in the seawater, the seawater gets inundated into the seashore area. This sulfate which is present in this compound, it gets reduced and forms this S2 minus, that is the sulfide compound. This sulfide compound it gets reacted with the iron and H2 which is present and it forms this FeS2, that is the sulfide compound. This sulfide, this H2S or FeS2, again it is released into this soil. So this iron sulfide containing soil, when it undergoes this oxidation phenomena, then the oxidation takes place and the soil becomes more and more acidic. Here the soils are becoming more and acidic. When soils are firstly drained, then the reduction phenomena takes place. Then the acidity of that particular soil is very less. If the soils are more and more oxidized, I mean, if the sulfur containing iron sulfide containing soils are becoming more and more aerated or waterlogged condition, then the soils become more oxidation takes place, repeated oxidation takes place, then the soils become more and more acidic, having the pH less than 4. So types of acid sulfate soils. So first is the potential acid sulfate soils. So in the potential acid sulfate soil, these soils are not oxidized. I mean, these soils are in the reduced condition. These soils are also known as cat clays, which is derived from the Dutch word catty clay growing dung. So the catty clay growing dung, which means the cat excreta. So cat clays in the Dutch word is termed as the catty clay growing dung. So catty clay growing dung is a cat excreta. So that cat clays resembles in form of the cat excreta or the yellow color formation, yellow color, it resembles the yellow color in nature. It seems like the pyrite mineral which is formed in the acid sulfate soils also seems to be in yellow color. That is why this cat clays in the Dutch, it is known as the catty clay growing dung. Usually these soils have the pH 6.5 to 7.5, I mean pH less than 4. These soils are unoxidized in condition having iron sulfide mineral in them. These soils are usually sticky in nature, saturated with water. They are very soft, sticky in nature, and they are saturated with water containing more amount of organic matter. And these soils are gel-like in structure, gel-like muds, and they are wet in nature, and they are potential to produce acid if they are exposed to the oxygen. So here you can see the diagram where the potential acid sulfate soils. So when these soils are in this manner, these soils are very soft and sticky in nature. And then, I mean, it is soft and sticky in nature, but it is saturated with water containing organic matter. It is in reduced state or in unoxidized state. These soils are less acidic in nature. Actual acid sulfate soils. Actual acid sulfate soils are those soils which are in a oxidized condition. So these soils, the soils which are formed here, the soils which are formed in the potential acid sulfate soils, when it undergoes repeated oxidation, then it forms the sulfuric acid. Those are known as the actual acid sulfate soils. These soils are more and more acidic. It is because of the presence of the sulfuric acid or formation of the sulfuric acid. These soils have the pH less than 3.5 pH. As these soils are generally very light in texture, very light and dry in texture, these soils have the mineral that is a jarosite mineral. It is a yellow color mottle, yellow color mineral. So here you can see the diagram where there is formation of actual acid sulfate soils, where there is a yellow color formation in the soil. This yellow color formation is due to the presence of the mineral that is jarosite. So the same thing is repeated over here. The sulfate which is present in the waters or in the soil with a combination of organic matter. So it gets microbial reduction takes place. Microbial reduction takes place in the surface water, and it gets converted to the sulfide. So this formed sulfide, that is S2 minus, it gets combined with the metals like iron and H2, that is FeS2 and H2S, and it forms this hydrogen sulfide or FeS2, that is the pyrites mineral. So this is formation of the potential acid sulfate soils. When these potential acid sulfate soils, when it undergoes oxidation phenomena, then this sulfide which is formed, it gets oxidized, it combines with the water and forms the H2SO4. It forms the H2SO4, becoming more and more acidic. That is known as the actual acid sulfate soils. So let's see the indicators for the development of acid sulfate soils. So how to indicate there is formation of the acid sulfate soils. So in the indicators, in the physical features, generally the soils are undisturbed. So in the undisturbed soils, these soils are wet color, they are saturated, and they are not easy to walk as the soils are in waterlogged condition over a long period of time. And also they are sticky in nature. These soils are in an anaerobic condition. The soils resembles in form of blue, green or grey color tint appearance. Organic matter is present or organic materials are present in these particular soils, and by the decomposition of this organic matter, the organic acids are also released. And this soil seems to be, the undisturbed soils seems to be have the rotten egg smell. So this rotten egg smell is felt in these undisturbed soils. So this rotten egg smell is due to the presence of the or due to the formation of this H2S gas, that is the hydrogen sulfide gas. So this hydrogen sulfide gas is formed by the breakdown of the sulfur and organic materials, thereby releasing this hydrogen sulfide gas. Due to the presence of this hydrogen sulfide gas, the smell of the soil seems to be the rotten egg smell. This is one of the physical features where we can indicate the development of these undisturbed acid sulfate soils. Let's see the oxidized soils. So characteristics of oxidized soils is, so these soils are very dry in nature and have the blocky structure appearance. These soils seems to be having this dark to the pale brown color. Gray color is replaced by the dark and pale brown color as the soils are getting more and more oxidized. So here you can see the diagram of formation of these oxidized soils. So this gray color is replaced by the dark and pale brown color. Where the soils are oxidized, we can say that the soils are being oxidized because of this appearance. So the oxidized soil seems to be appearing in form of orange mottling. Mottling is nothing but the mixture of different colors, mixture of different tints of the colors. The dark brown to pale brown or gray color. So it is known as the mixture of the colors is known as the mottling. So yellow color bottling is due to the presence of the mineral that is known as the jarosite. So, so the thickness of this mottled layer, I mean the thickness of this mottled layer depends upon the degree of development and also the soil moisture or the water content present in that particular soils, and also the field test results. The pH of that particular soils also determines this nature of these oxidized soils. Potential acid sulfate soils may be present under the actual acid sulfate soil layer. The chemical features of these actual acid sulfate soils. So in the chemical features, the pH is the main criteria to determine this the actual acid sulfate soils. So the pH, if the pH value is less than 4, then the soils are termed as the extremely acidic soils. I mean the soil category comes under the extremely acidic soil having the jarosite mineral present in them. If the soil pH is less than 4.5, then it comes under the category extremely acidic category having a mineral that is known as the pyrites. So this pyrites is been it is present in the soil having the highly organic matter, and it is present in the unoxidized condition. If the soils have the pH 4.5 to 5.5, then it comes under the category very acidic soils. If the soils have the pH 6 to 7, then it is termed as the less acidity or no acidity, which is generally present in the undisturbed acid sulfate soils or in the unoxidized conditions of the acid sulfate soils. So science in the environment. So in the science in the environment, generally first is the water. So the water quality, so we can determine this formation of these acid sulfate soils by seeing the water quality. So the water quality is more affected with the formation of these acid sulfate soils. It is because of the acid sulfate soils have the high pH condition, sorry, low pH. So due to the low pH condition, there is development of these hydrogen and aluminum ions, and also the release of heavy metals present in them. So because of the release of these hydrogen, aluminum and other heavy metals into the environment, so this water appears in form of the blue-green tint appearance. Blue-green tint appearance is the appearance of water by the which we can determine the formation of these acid sulfate soils. Reduced iron. So because of the presence of these reduced iron conditions, which is formed from the acid sulfate soils, where the vegetation seems to be like a orange scum. Orange scum, it is a appearance where the vegetation seems to be appearing in form of orange scum, which is formed due to the reduced iron condition. Next, next point is that formation of this oil film. Oil film appearance, it is formed by the iron loving bacteria. So because of the iron loving bacteria, the oily film is formed on the surface, on the flowing waters. I mean on the slow moving waters, this oily film which is formed by the iron loving bacteria. This is also one of the criteria to determine this acid sulfate soils present in the water. So next is the soils. So generally the acid sulfate soils are, when these soils are in undisturbed condition, these soils are wet and waterlogged condition. They are soft and sticky in nature. Those are known as undisturbed soils. When these soils, undisturbed soils, when these soils undergoes this oxidation phenomena, these soils become dry and having the blocky structure in them. So because of this, the soils will become soil will shrink irreversibly due to the presence of water and forms the cracking. Cracking of the soil and shrinking of soil takes place as the soil becomes dry and blocky appearance. And also poorly managed structure, poorly managed construction. So when the soils are poorly managed, we can see the sinking problems. So sinking problems are generally seen in this formation of the acid sulfate soils, where the saturated soils can bear only the light loads, whereas the heavy loads can compress them. If heavy loads are dumped in the soil, or when it is heavy loads are kept in that particular soils, they get compressed. These soils, these acid sulfate soils are generally found in lowland areas, estuarines, mangroves, deltaic regions, in various countries like Bangladesh, India, Vietnam, and Australia. Next is the vegetation indicators. So there are three types of vegetation indicators which we can identify these acid sulfate soils. So three types of vegetations includes this acid tolerant vegetation, salt tolerant, waterlogged condition. So in the acid tolerant vegetation, so this type of vegetation is directly related with the acidic environments. Salt tolerant vegetation is usually present in areas like estuarines or swampy areas where these acid sulfate soils are formed. In the waterlogged conditions, it is generally formed in the swampy areas. So here you can see the picture which determines these acid sulfate soils are which are dry. These soils are becoming, these soils became, there is very less vegetation. It is because of these soils are more and more oxidized. When the soils are more oxidized, there is a presence of sulfuric acid mineral, sulfuric acid which is present in them. Due to the presence of that more acidic nature, the vegetation is being declined or very dead vegetation is present in that particular area. Infrastructure effects. So in the infrastructure effects, the acidity, so the acidity releases H plus and aluminum and iron ions. So when these metals are released into the environment, into the soil, so these metals attack the concrete and also the steel structures of the buildings. So with the concrete, the corrosion can be rapid. The corrosion happens with the help of the metal, the iron which is released from these at low pH soils, the iron compound which is released undergoes this corrosion. Because of this corrosion, the red color appearance which is visibly seen on the canal walls, base of the bridges and also the road culverts. So this is the formation of this. This is the effect of the acid sulfate soils that have the more effect which we can see on the canal walls and also the base of the bridges by the release of the heavy metals and also because of the low pH condition. Characteristics of acid sulfate soils. So acid sulfate soils have the sulfuric horizon having the pH less than 3.5 and it has the mineral that is the sulfur containing mineral that is the jarosite. So jarosite is the it is a combination of both sulfur and iron containing mineral which appears in form of yellow color and also the yellowish brown mineral that is Shewart mannite. Shewart mannite is another mineral which is also present in these acid sulfate soils. So soil color is determined by the Munson color chart. So these acid sulfate soils have the hue value that is 2.5Y and also more than, even sometimes more than that, which has the chroma value that is 6. So generally these soils have the more amount of pyrites. So that is why it is known as a sulfide soil minerals. The soil organic matter ranges from 1.5 to 1.8%. CEC cation exchange capacity is of 10 to 25 million milli equivalent per 100 grams. Usually the minerals like or the elements like nitrogen, phosphorus is very low. There are many toxic elements like iron and aluminum having this and also the H2S toxicity. When these soils are first drained, they're having the neutral in reaction or having less acidic. When these soils undergo more and more drained or aerated conditions or in waterlogged condition, then these soils cause the lethal damage to the crops. Causes of low productivity in soil. So why these acid sulfate soils are less productive in nature? It is due to the various factors which include this release of as the acidity of the soils is very low pH, there is excessive release of these hydrogen, aluminum and manganese ions or sometimes the toxicity of these elements takes place. So due to the toxicity of these iron, aluminum, manganese, there is decreased availability of nitrogen, phosphorus, and also the molybdenum. Due to low pH, there is low base saturation. All the bases are being leached down, are leached out, remaining only the H plus and aluminum ions, as these ions are insoluble in water. Abnormal effect of the mycorrhiza, abnormal effect of the mycorrhiza takes place, and also the virulence of plant disease. There is the attack of plant diseases. There is more attack of plant diseases due to the less pH condition. Toxicity of this H2S compound leads to the lowland rice. So the toxicity of this H2S occurs in the lowland rice, which is causing a disease known as the Akiokai disease. So Akiokai disease is generally seen in the lowland rice crops is because of the H2S toxicity. So when there is more amount of H2S toxicity, this the roots of this rice seedling means so it prevents the rice roots to absorb the nutrients from the soil, thereby causing the decrease in yield, and finally the death of the seedlings takes place because of this H2S toxicity and production of more and more organic acids because of the presence of the organic material. Organic matter is present in the waterlogged condition as and the decomposition of this organic matter releases more amount of organic acids, making the soil more and more acidic. Some facts about the acid sulfate soils. So in the submerged condition, the sulfate which is present in the water is reduced to the sulfide, and it is oxidized to the sulfite is reduced, and it is converted into the sulfide. Generally, these soils are less acidic in nature. When these soils are drained or aerated, the sulfide, which is the sulfide or elemental sulfur which is present, it gets oxidized and forms the sulfuric acid, having the pH less than 4.5. These soils are also known as the cat clays or catty-clay growing them, which is the Dutch word. As most of the soils are the plants uptake the nutrient of sulfur in the sulfate form. In India, acid sulfate soils are mostly found in the regions that is Kerala, Orissa, Andhra Pradesh, Tamil Nadu, and West Bengal. So these are the areas where there is dominantly present of these acid sulfate soils. Problems related to the soil acidity. So there are different problems which include the soil acidity, soil salinity, aluminum toxicity, iron toxicity, low nutrient contents because low base saturation, hydrogen sulfide toxicity. So here you can see the pH value, that is pH is less than 3.5. Reclamation and management measures of these acid sulfate soils. So in the reclamation measures, so prolonged submergence, if the water is morely prolonged, if the water is submerged over a long period of time, then the soils become less acidic. Acidity will be there, but the soils will be in the range of that is 5.5 to 6.5 range will be maintained. The acidity will be maintained in this range when there is prolonged submergence condition. Leaching with rainwater, seawater, or in succession with them. So when the leaching phenomena takes place, all the salts will be removed. Then the effect of salts can be managed because of this leaching phenomena. Addition of lime and also manganese dioxide. Addition of lime is one of the reclamation measure used in order to decrease the acidic condition. So by the usage of this lime, the pH of the value is increased, thereby the acidity of that particular soil can be decreased by the application of liming material. Different practices like ridging, growing of acid tolerant crops, deep ploughing to mix calcareous horizon, liming fertilizer application, water table control. So these are all the measures, practical measures which can be done to reclaim these acid sulfate soils. Water table control is one of the major measure which we can do. So water table control, when we do this water table control, the soils can be so when the salts are maintained, when the salts are controlled in this water table, then we can reclaim this, or we can decrease the amount of salt content present in them, thereby reducing the formation of acidity nature in the soils. Improvement of drainage, and leaching out the soluble salts repeatedly. Leaching out the soluble salts. When the leaching phenomena takes place repeatedly, all the salts will be leached down, making the soil very less acidic in nature. When the salts are leached down, soils become less acidic in nature, thereby the acidity can be maintained. According to the Bandyopadhyaya, beneficial effects of lime leaching and M&Moto application can be done in order to improve the acid sulfate soils. According to the Manorama, suggested that lime can be applied in small quantities or in the short intervals in order to minimize the effect of the potential acidity of the soils, thereby soil acidity can be controlled. Mongia et al. He described that the effect of liming and also the application of superphosphate in the yield of rice can be maintained in the acid sulfate soils. Diverting saline groundwater into the disposable basins. So when the saline groundwater is diverted into the disposable basin, the more amount of salts are removed from that particular soils, maintaining water levels with temporary regulators. So this is nothing but the water table control. Reinstating wetting and drying patterns to wet soil and prevent the building of the sulfidic sediments. Rewetting and drying of the patterns. Wetting and drying of patterns can be maintained in the rice fields in order to remove the salts. When the salts are leached down, thereby the acidity of that particular soil can be maintained, which helps to give the more yield and the better crop growth. Applying the alkaline products such as the lime. So liming material can be done in order to reduce the soil acidity. So this diagram depicts the worldwide distribution of these acid sulfate soils, where the soils are present in the India, Bangladesh, Vietnam, Australia, and some parts of Africa. Thank you.